Hi, boys and girls, fourth graders, welcome back. Let's do lesson 12.3 today. So we're going to continue identifying number patterns and then figuring out a rule, and then we're going to continue to generate terms, which means filling out the rest of the pattern in the tables. So as a refresher, let's take a look at some multiples of numbers that we know. Multiples of 2, 2, 4, 6, 8, 10, basically all your even numbers. Multiples of 4, 4, 8, 12, 16, 20, 24, and so on. So you're skip counting by 4. Multiples of 8, when you get to larger numbers, you can think to yourself, 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32, 8 times 5 is 40, and so on. Multiples of 3, 3, 6, 9, 12, 15. You can keep going, that's why I'm putting the 3 dots there. Multiples of 6 are listed, and then multiples of 9. Okay. So these will be able to help us when we're working with patterns. So if we look at the table on the right-hand side of the notes, picture number 1 I've labeled down below. It looks like a block letter T. Picture number 2 has also been drawn for us. Now the number of squares in picture number 1 is 5. 1, 2, 3, 4, 5. The number of squares in picture number 2 is 7. Now they didn't draw picture 3, but they filled it in for us. So if we look for the pattern, we started at 5 and think, what am I adding or multiplying each time? So going from picture 1 to picture 2, we can see that we added one more across the top and one more going down. So I'm adding 2 each time. So I can finish the table by adding 2 and then getting 4. For picture 4, I'd have 11 squares. For picture 5, I'd have 13 squares without even drawing the picture. So the rule here is that we take the picture number and we're going to add 2 to it to get to the next picture. Why will there always be an odd number of squares? Well, we started with an odd number 5, and we know that anytime we have an odd number and we add an even number like 2, we're going to end up with an odd number as the sum. Let's take a look down here. So they want us to draw the next 2 designs for the prior problem. So that means up here we're going to draw picture 3 and picture 4. And again, remember what we did was for picture 3, we started with picture 2 and we added 1 across the top and 1 at the bottom. For picture 4, we did the same thing. We took picture 3 and then added 1 more square across the top and 1 down the bottom, down the column. Okay. And if we count the squares, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, we do see that that is exactly what we wrote up here. Okay. Now the last part of our notes, we have circles, and I've labeled the pictures. Pictures 1, 2, and 3 have been drawn for us. We can see that we're starting off with 2 circles. Now going from picture 1 to 2, I can see that I added 4. Picture 3, I build on top of picture 2. So picture 2 had 6, and I can see that I added 4 circles. So it looks like I'm taking the picture from before and I add 4. Okay, 4 circles. So I can finish the table by adding 4 as I move down the row, okay, across the row. Now it asks us, why is it never possible to have an odd number of circles? Well, we started with an even number, right? The number 2. And we know that we're adding 4 each time. So any even number plus another even number is always going to give us an even number as the sum. As a challenge, you can grab a piece of scratch paper and you can draw the next 2 designs for pictures 4 and 5 in this series. Thank you.